Okay, so this problem says how much heat must be added to raise the temperature of 1.5 mole of air from 25 degrees Celsius to 33 degrees Celsius at constant volume. Assume air is completely diatomic. Repeat the problem for the same number of moles of xenon. Okay. So for part A, for a diatomic, the problem is at constant volume. Okay. So for a diatomic molecule, gas at these temperatures, at room temperature, at around room temperature, CV is 5/2 R. So CV depends on temperature. Remember CV around, so for example, around 10,000 degree Kelvin is 7/2 R. And CV around 100 degree Kelvin is only 3/2 R. So it depends on the number of degrees of freedom. Remember CV is F by 2R. So F is the number of degrees of freedom. Okay, so at room temperatures, the number of degrees of freedom for a diatomic gas is 5/2 R. Okay, which we talked about in the lecture. Okay, so how much heat must be added? N, the number of moles of gas you have, times CV times the rise in temperature. Okay, and so this is N is for our case we have 1.5 moles. Well, okay, let me do it this way. And CV is 5/2 R times the rise in temperature. Okay, I'm going to add another page because I don't want to get scrunched up. So QV is N is 1.5 moles, 5/2, and R is 8.314 joules per mole per Kelvin. And delta T is 33 minus 25 degrees, which is 8 degrees Celsius. Okay, 8 degrees Celsius. And temperature rise by Celsius is the same as Kelvin. Okay, so actually I'll just do Kelvins here, so that way Kelvin will cancel. Okay, so this much heat is what you need to add, and that will work out in joules. The moles will cancel with this mole, Kelvin will cancel with that. Okay, so to warm air, 1.5 moles of air, you have to add 250 joules of heat to warm it from 25 degrees Celsius to 33 degrees Celsius. Okay. Now, what if you were using xenon? Xenon is a monoatomic gas, and CV is F by 2, R is 3/2 R. A monoatomic gas only has 3 degrees of freedom, and that's true at all temperatures. Okay. So QV is N 3/2 R times delta T. Okay. So all you have to do is, this is 5/2 R, this guy is 5/2 R, so just divide that number by 5 and multiply it by 3. So divide that by 5, that's 50, times 3 is 150. So roughly 150. Okay, so let's do that. 249.4 divided by 5. All right, so what we are learning is the following. What we learned is the following. To warm up a gas that had more degrees of freedom by 8 degrees Celsius. To warm up a gas that had 5 degrees of freedom by 8 degrees Celsius took us 250 joules. To warm up another ideal gas that had only 3 degrees of freedom by the same temperature, you warmed it up by the same temperature, but you needed only 150 joules of heat. Okay? So the more complex the molecule, the more energy you need to warm it up. Okay? So that's what you're learning. All right.